In this video, I am going to talk about detecting a cycle in a linked list. Let's suppose we have a linked list 2, 3, 4, 5, 6, 7 and having a cycle from between 4, 5, 6 and 7 nodes. So how we can detect it? So one way to let's think about it. The one way to solve this is once we start traversing from the head, we can we can keep a set and we can check whether that particular node exists in the set or not. If it exists, it means there is a cycle and we found the cycle. Else, if we reach to the end of the list, it means there is no cycle. What I mean by that is, let's say we traverse up to 2, 3 and 4, then the set has the addresses of 2, 3 and 4. Now let's say I reach up to 5, 6 and 7. At that moment the set has the elements 2, 3, 4, 5, 6, 7. Address, basically address of 2, 3, 4, 5, 6, 7. Now at 7, if I traverse the next element, which is 4, and I will check is 4 in my set, and I immediately get back yes, 4 exists in the set, then I immediately know that I had a cycle, and I will return back that yes, I found a cycle. To find out that, we have to traverse till the entire list up to the 2, 3, 4, 5, 6, 7 and again up to the 4. So we can say the order of detecting the cycle is order n. But we also has order n space complexity, because we need to keep a set for all the nodes we have traversed so far. So we are traversing as well as we are keeping the information. So can we do better than that? Can we reduce the space complexity? So in this case, let's imagine a situation that we have a circular track, and on that track we have two players A and C. C runs twice. C runs faster than A, and how much faster? Twice. So let's say in the same time A takes one step, C goes for 2 steps. So like this. So A take 1, C went for 2. Then similarly again A took 1 more and C took 2 more. So in the same time C travels 2 steps. A travels 2 steps, C travels 4 steps, and in the end they basically cross each other at this moment when A travels 3 and C travels 6 nodes. So what we are seeing here, so in a circular track, irrespective of the position of A and C, if one travels twice compared to the others, they will cross at some point on the track, right? Because the amount of time, irrespective of their position, the amount of time in which A go for X, C go for 2x, and at one point or the other point of time they will definitely cross each other on the track. So can we use the same concept in our linked list? For example, let's say we have this linked list. We started with 2 and we reach 3 by taking 1 step, and we reach up to 4 by taking 2 steps. So we can say one is slow pointer, another one is the fast pointer. Now the slow went for 2 steps, fast went for 4. Again slow travels 3, fast travels 6. Next, when slow travels 4, fast travels 8, and they meet at 6. So at the 6, when they both intersect each other, it means from this we know that we had a cycle because they both reach to the same position. So can we code it now? Let's try. So now let's code it. So if head is equal to null pointer or head next is equal to null pointer, we can simply return false because in that case we don't have cycle. Now let's say slow is head into next and fast is equal to slow into next. So what we are doing here is we assume that slow has already moved to 1 position and fast has already moved to 2 position in the beginning itself. Now we say while fast if slow is equal to fast, then we can return true because we detect the cycle. Else we can move fast is equal to fast into next and if fast slow is equal to slow into next and fast is equal to fast. If any time we reach the end, then we can just simply return false because we don't have cycle. Thank you.